Hello everyone, I hope you're having a wonderful day here. We're going to introduce you to Tukey fences and Z-scores, maybe a review to you, but it's always a good practice. It's a very important and quick thing to do to kind of start to understand if we have any outliers based on standard deviation and mean and things like that. So we're going to look at a file here related to Cardinal hardware. And what we have here is we have salespeople. So RFQ stands for request for quote. So we have sales, request for quotes, and we have win-loss. So what this means is we have a first name, a last name, and I'm going to bump this up for us. Okay, first name, last name, and we have the region that the salesperson is in. We also have years with the company, excuse me, and we have RFP 1. So that was the quote or proposal that was sent out. We have the volume on that order, and we have whether we won or lost based on that order. Now that product, it's a particular product, it's a bolt. The product itself is not important, but all of these are for the same product that was quoted. So this quote here is for 18 cents. We always want to make sure, because when we're dealing with small numbers here, in fact, let's bump this out so that we know it's not just 18 cents. So 18, so 0.1833, and you can see down here that those, when you're dealing with almost 3 million in volume, those last 3 digits or last 2 digits, they really do matter. So this is for, in total, the volume is 256 million. How do I know that? Because I highlighted this and I went down here to this horizontal bar at the bottom, and it gave me all these lovely statistics. Now, if you don't have this, right click anywhere on this little area here, this light gray, and you're going to get a bunch of stuff that you may have never seen before in your life. And by default, some of these are not selected in Microsoft Excel for you, so you'll want to check mark those if you want to find a quick way to get some information about your data. So I can go here and I can find that I had an average quote of 0.2326 and a minimum of 0.0001, ouch, and a maximum of 80 cents. So quite the gambit here. If I did a histogram, or if I did some sort of a line chart or column chart, anything along those lines, I would find quite the spread, because the average is 0.23. So that means most of the values are on the left side, because if we had a 0.4, then it would probably be right in the middle, or a 0.7 would be towards the right if we're talking about the shape of our data, something that will come up. So by just quickly playing around with the average and looking at the min and the max and things like that, you can start to get an unofficial view of your data. Okay, so the win-loss is profiling the data here, doing some canvassing of the data. I have 123. So that means out of 200 numerical rows, I have won 123. So over 50% of them have been wins. So a data analyst, data scientist might decide, how can I use this report, or how can I develop this report further and refine it for the decision makers? Because certainly they don't want to go through 200 rows of data every single time they want to analyze something. So could I do a correlation between years with company? Yes. However, this is text. And even if I were to put 7, 7, 4, that would take a long time for us to clean that up. So in future weeks, we're going to actually address that. Now, what we want to do with this assignment, however, is simply do some Tukey fences and some Z-scores. That's all we're going to do here. So we're going to look at these two here. It doesn't make any sense to do these because we only have 2 values, 1 and 0. So a Z-score and a Tukey fence isn't going to support anything. It'll error out for us. There's not enough variety in the data to do that. So we're going to go ahead and do some Z-scores and some Tukey fences with this data set. Hello, everybody. A couple of things that I'm going to do here. I'm going to do the Z-scores first because they're very simple to do. And Tukey fences do take a little bit of time to set up. So we're going to do the Z-scores first. Before I begin, I am going to normally do this, but I'm going to insert some rows up here just for demonstration purposes. and I am going to show you the calculation for z-scores so that we have that right there for us. So keep in mind that you may not be needing to do this. Your spreadsheet will likely differ now because you're not required to submit this assignment as a spreadsheet, but there you go. So we're going to do a z-score for RFQ and z-score for RFQ1 volume. Okay. And just so we're clear, that's RFQ1 as well. So just so we're clear there with our data inc, and it matches up nice and neat. Not required to complete this assignment, but for demonstration purposes, I wanted to make sure that that looked good to us. Okay, so the formula is X, so the particular value that you're looking to test. So a z-score is a test. You're testing whether that value there is greater than a 3 or less than a -3, if that makes sense. So Excel sometimes yells at me when I do this, but we're going to do, it actually worked there. So sometimes Excel doesn't like those pluses and such, so be careful of that. So we want something that is, well, it's an outlier if it's greater than 3 or less than the -3. And there we go. There's where the problem is. I knew there's going to be a problem with Excel, the way that it likes that stuff. So I tricked it by putting an apostrophe up there. There you go there. So we're trying to find that spread away from 0 and away from those 3s on both ends of the 0. So, okay. So we're going to use this formula. We're going to grab this cell here as the X minus the average function, because Excel does not have a mean function. Shift control down, that is not required. It's just a trick that I have to speed things up. And I'm going to also put that in brackets too, because I want this formula to work first. As you can see there with the brackets there. Otherwise you can get all negative numbers. Don't ask me how I know. Okay, so now we're going to do standard deviation, and I like the classical form of that. So left click there, shift control down to get my range. You don't have to use that trick if you don't want to. Close the bracket, and I've got my z-score of 0.4, or rather -0.4, which is still pretty close to 0, so we are not too concerned about that value. Now, because I inserted these rows here for demonstration purposes, I need to absolute cell reference some things up here. Normally, I would just grab the whole column and not have to worry about that, but in this case, I don't want to lose those reference points. Okay. So now we can drag this down and look at our wonderful z-scores for each individual data point. Okay, now these numbers look pretty standard, but again, our friend down here that I introduced you to before, the average is 0, which is what we want. If you think about what a z-score is, distance from 0, it's stratifying things, it's standardizing the data and calculating for distance, so you want to see an average of 0 or very close to 0 mathematically. If you don't get that, then you did something wrong. If you work on this in the field, you might have applied something incorrectly. Most often, people forget to use those closing brackets there. The ones that I did there. That's number one error that I see people do when it comes to this stuff. The other thing is, if you look down here, you can quickly tell 200 rows of data, the min is -1.7 and the max is 4.1. In other words, I do have at least one outlier in this data set. How do I know that? Because of the rule of 3. It's greater than 3, then there's an outlier. And we have a 4.1. We might even have more than one. We might have a 3.7, a 3.01, 3.17, 3.33. We don't know yet, but a quick snapshot tells you, hey, we got an outlier in here that we have to address. In terms of data science strategy, that is important, because if I had a min of -1.7 and a max of 2.3, then I know that I don't have any outliers according to z-scores, and I could probably move on with my life. Okay, so that's the data science strategy involved in this. However, because I know I've got an outlier, I now have to take a different approach to my work and identify those outliers and identify whether I need to remove them from the data set or if I can go with it. Okay, so that's the purpose of the data science strategy element of looking at Z-scores today. Now we all know, or you may not know this, but I do believe you worked on things like this in previous courses. We could do color scales here to show magnitude. We could also do highlight cell rules where it is greater than 3. So greater than 3. And there's one there. There's our 4.1. Look at that there, 80 cents. There's our 80 center. And whoa, look at that volume. Any other outliers in here? Does not look like it. Why did I not do the -3? Because our quick math strategy behind this showed me that there is no possible value that's a negative outlier. So I didn't waste my time doing a color scale or data definition for conditional formatting based on that. Again, I want you to think of data science strategy, not just strategy in organizations, but being strategic and smart about your work when it comes to data science. It's important to be comprehensive, but it's also important to not put the majority of your time in places that don't yield results as well. So, want to know a beautiful thing about this stuff? If we absolute cell reference the columns, then we would have to drag them across. But because we did it this way, all we have to do is drag this formula over, double check our work. We got this one here that we're looking at. We're looking at the average of them, and we're looking at the standard deviation of them. We don't have to retype these formulas. We got it all. Again, that's data science strategy, being smart with your work. Look at all these outliers. Wow, we got an outlier there. Same one right there. Doing the same stuff here. We got a -0.7, so nothing there. And we got that 3.0. I love how Excel, sometimes it thinks it's smarter than you and it does things wrong, but this time it copied over that conditional formatting. So we didn't even have to go up here to do that work. So it looks like we found one outlier here. Now you could certainly create a histogram if you want, or a pivot table that shows you the spread or the shape of the z-scores if you wanted to. You're totally allowed to do that. That's actually recommended, so you can better understand your data. Because what if there was a 2.9 or 2.99 or something along those lines that you might also want to look into depending on your industry. Additionally, the default here is a 3, right? The rule of 3. But just like in Star Wars, you can also implement a rule of 2. Please send me a message if you caught my Star Wars reference there. That would make my day. But anyhow, if your company is more sensitive to outliers, you could change that to a 2 or a 1. No, a 1 would bring back quite a few z-score results that would suggest outliers, but you could play around with this. Nothing says that once you develop this, that you can't say, you know what, I want to investigate this number here or that number there because it's pretty high, even though it's not traditionally greater than 3 or that rule there, but it might be worth looking into. So again, data science strategy here, it's not about what's in a textbook or what's in a page. It's about what makes sense to your company. What's the strategy play there? So the answer to this data set is there is one outlier for the RFQ1 and one outlier for RFQ1 for volume, and it just so happens that it's the same value. Now, it doesn't have to be, so keep that in mind. It doesn't have to be. You could find that the value is just fine. Let's just chop this down here for an example. Look at that. It doesn't mean that it's going to be an outlier over here as well. In fact, is there any outliers? Nope, there's none. 2.7 is the highest one. So again, I'll undo that with a Control Z. But again, think about the strategy here. Think about the purpose. Think about why you're doing this. Think about the allowed tolerances that your company is willing to work with. I mean, obviously, this is a big number here, right? It's a very big number. But imagine you weren't just dealing with 200 quotes for a particular product. Let's say that you had all the quotes for all million products that your company had. Now, ideally, you do some math like this in a SQL table so that you don't have to have all this stuff in an Excel sheet, because again, that's data science strategy. But the same rule would apply here, is what does make sense for your company. Okay, so that portion of the Z-score calculations is over. Let's move on to Tukey fences in a moment. Okay, Tukey fences takes a little bit longer to set up, so I brought over some information from our page in the course. So step one, calculate the interquartile range. And in order to do that, we have to find the third quartile and the first quartile as well. So to do that, we're going to use the percent or the quartile function in Excel to find them. So I've got some stuff over here, just some headers, if you will. We're going to play around with this a little bit. It's not as clean as doing those Z-scores were. So interquartile range, remember what that's going to be. So we'll hold off on that. That's Q3 minus Q1. So we can go ahead, Q3 minus Q1. It'll be a 0 for now. So to calculate Q1, we're going to do quartile. Okay. And we're going to grab our range. So in this case, we're going to do RFQ1 first. Shift Control down to get those values. And we're going to put a 1 because we want quartile 1. And there's our data right there. Okay. Now we want to do the same thing here. And if you're clever enough, your data science strategy is at play here. We don't have to type all that in again. We can go up here, copy, paste it down here. Yes, we have the same value, but let's change that 1 to a 3. Boom, we got another number. Okay, so now we have our interquartile range of 0.21, which is the difference between Q3 and Q1. So we have satisfied the first step. Now we need to calculate the lower and upper fences. Okay, so we're going to move over here and we're going to calculate the lower fence. I know this is messy. Upper fence. Okay, move these over for us so we don't get too chaotic over here. But so lower fence is Q1, so equals this minus 1.5 times the interquartile range. There you go. So 0.12 times 0.21, or sorry, minus 1.5 times this. So that'd be like saying this times 1.5 and subtracting off this piece. Okay. Now, if we're clever with our data science strategy approach, we can take this formula right here and bring it down here and not have to type in any other stuff again. However, obviously, we're going to have to bring this down. So we have that number there. And yeah, we got a 0.02. But don't leave it at that, because there's one thing we have to change. See how it says minus here and plus here? We have to go up here and change that plus. So while your data science strategy might say, hey, I can copy that formula down, please make sure that you're adjusting that formula where appropriate. So now we have our lower fence of 0.19 and our upper fence of 0.66 and change. Okay, now that's for the RFQ1, not for RFQ1 volume. Okay, we're going to look at RFQ1 here in a moment and calculate that out. Okay, now this is going to be a trickier part here, so you've got to pay close attention. We want anything that is less than the lower fence or greater than the upper fence. Okay, so this is similar to that Z-score rule of 3 stuff. We want something lower than something or greater than something. Okay, and we need to be careful here because we need to reference 2 different numbers and not just one. And we're going to use what's called the if-or function. So if-or, so we can have 2 logical arguments there. So if this number is less than this number, comma, that same number, so E8 is greater than, see, I almost made a mistake there, is greater than this number. Close your parentheses. Okay, we'll put a 1 for yes, 0 for no. We'll close that off, and there we go. So, is 0.18 less than this one? Nope, it's not. Is it greater than this one? No, it's not. So that's why we got that 0. Now, as I said before, this can be dangerous, complicated. If I simply double-click this and drag down, I will certainly get some information. However, we need to absolute cell reference that stuff. Otherwise, look what happens. It drags those references down. So we need to absolute cell reference the rows over here for this data. So we're going to go ahead and we need to absolute cell reference the references to the 3rd row and the 4th row. Okay, so $sign, and we've got it. Now we can double click and drag down. And once again, if I look here, I know I have one outlier, and lo and behold, look where it is. It's the same one. So Tukey fences, while it's not as, it doesn't give you a score per se, you certainly could try to create some division problems, such as instead of 1 or 0, you could divide it somehow. Whereas a z-score gives you a quick and easy magnitude as its innate or inherent response. So Tukey fences for RFQ showed up in the same exact spot. Now keep in mind, you don't have to use 1.5. If your company is more sensitive or more generous, you could change that 1.5. You could drag it down to just a 1.1 or a 3.0. Really depends on your company and the data science strategy involved with that. It's not set in stone. You certainly are allowed to adjust it based on your specific data and tolerance for outliers. Okay, so now that we have all that set up, we could end this, but we want to do one more here. So what I'm going to go ahead and do in this video is I'm just going to set it all up for us and then talk through it. Okay, so I'm back and I set it all up for us. I cleaned it up a little bit for demonstration purposes. And quite frankly, all I really had to do is copy this over. I did have to change the cell references over here a little bit, but it didn't take much work at all. So I've got an interquartile range subtracting these. I've got my quartile for 1 over here to volume. Be very careful when you do your work. If you're going to just do this and bring it over, see what happens. You're actually grabbing this. You're not grabbing this column over here. So be very careful if you're going to try to work ahead, or if you think you have a solid foundation on this and then you find out, oops, it's not panning out how you thought. So we got this back. We've got our lower fence of negative 2 million and change, and almost 5 million on that side. So the same kind of formula over here. Let's just copy this because we can. We'll just drag this over so that we have the correct fence information. We also want to make sure that we're bringing this over here. There. And we've got our formula. So double click. And we have 15 this time. So folks, isn't that fascinating how the Tukey fence found just 1 for the actual price, but this time it found possibly 15. Now you do want to double check everything, double click your formula, make sure it's referencing everything you thought it was going to be referencing. And it's referencing this, very good, because sometimes things can go astray if you miss an absolute cell reference. But isn't it interesting how these are all lining up as outliers right in here? Let's take a look. Is there anything unusual here? Not really. I mean, yeah, right in here, there's some outliers, but why does it stop over through here? Not really outliers over in here. So just really interesting here. I mean, we have a bad quote there. There's that one quote we were looking at or talking about with the 0.0001. So we've got that going for us right in there. So S3 and S4, make sure we have that correct. S3 and S4, perfect. So it looks like we have 15 outliers for the volume. and just one for RFQ for Tukey fences. So I know that was a long journey through all of this, but as you can see, Tukey fences and Z-scores, while similar, it's about a distance from objects, they do look at things a little differently out there as well. So both can be useful as a diagnostic to double check your work, to be very thorough and the like there. I will say that Tukey fences are used much more in data science when you're doing data mining projects where you have perhaps Python or other programming languages able to analyze billions of rows of data. If you're looking at every single transaction in a company, in this case, we have fixed quotes, so there wouldn't be billions of quotes out there, you know, but hopefully this was a palatable experience into Tukey fences and seeing how, well, we could have one error here, but 15 over here. So thank you.